Now we'll discuss about unit 3, right? These two problems are there in the unit 3. So you'll get 20 marks from the unit 3, 5 marks theory plus 15 marks problem. So here the question is, design a simply supported beam of span 5 meter, right? 5 meter carrying a reinforced concrete floor capable of providing lateral lashing to the top compression flange. The beam is subjected to the dead load of 20 kN, that is dead load excluding self weight. So you know to self weight, again you have to assume here the self weight is not included, only dead load is given. Then the imposed load or service load or live load, that is 13 kilonewton, 30 kilonewton per meter. Assume Fe is equal to 410 grade steel, that is Fu 410. So given Fe 410 steel, that is Fu 410 Newton per mm square. Fy is 250 always. Dead load, that is given as 20 kilonewton per meter excluding self weight, and imposed load 30 kilonewton. Span is L 5 meter given, that is 5000 mm. So dead load is 20 kilonewton. First it will be load calculation, that is 20 kilonewton dead load. Then self weight, here they given excluding, that is why you have to assume self weight, that is 0.8. You can assume up to 0.7 to 1.2 also. So we will assume as 0.8 kilonewton per meter, assume. Then live load is 30, they given. Total load is 30 plus 20 plus 0.8, that is 50.8. So Wu, that is ultimate load, is 1.5 into W, that is 76.2 kilonewton. Then we have to calculate moment at ZP. Bending moment formula is WL square by 8. If they give simply supported, here in the question they given simply supported beam. If they give simply supported beam, the M value is WL square by 8. If they give cantilever beam, then M value is WL square by 2. Remember properly. Okay. M is WL square by 8. That is WU, right? 76.2 into 5 square. L square is 5. That is 5 square by 8. You will get 238.12 kilonewton per meter. You need to remember kilonewton meter, not per, kilonewton meter. I have to convert that into Newton mm. Newton mm means I have to multiply with 10 raised to 6. Okay, anyhow we got the moment value. Now we have to calculate plastic modulus, that is ZP value. ZP value plastic modulus, that is M into gamma m naught by Fy. So M is 238.12 to 10 raised to 6, gamma m naught is 1.1, Fy is 250. You will get ZP value in terms of mm cube, that is into 10 raised to 3 mm cube, or else 1047.72 cm cube. You have to eliminate 10 raised to 3, then you will get in terms of centimeter cube. So I have to go to the code book now, where I have to go for 138 page number, right? Page number 138. I'll show. They will get ZP value. We got ZP value of 1047. For the ZP value of 1047, we have to take a ISMB section. ISMB should be there. There is no ISWB and all. ISMB 400. Why I took 400? Because the ZP value should be more than 1047. This is the required ZP, and I need more than that ZP value, and should be ISMB. So I'll show the steel tape code book, then you will be easy to understand. Okay, page number 138. So here page number 1, this is page number 138. Okay, there will be a table given like this. So here the ZP value will be in the 9th column. This is ZP values, right? In the ZP values we can check more than 1000. How we need 1047 something. So we need that. More is 1099. You can check the section here. Here wherever ISMB will come. This is ISWB, ISLB, ISMB 400, right? ISMB 400. Along that you can check here. That is 1176. We required 1043. This is 1176. So ISMB 400 is adopted. Two things should be in the mind. One, ZP should be more than whatever required, and this section should be ISMB. Wait. Okay, and the values here, right? Whatever the values, H values, this for the ISMB 400. Where we got ISMB 400, here we got ISMB 400. For that values you have to find out first This all these things you have to return. Sectional area should write D value, that is H value or D value, then BF, then TF value, then IXX value, this thickness of the web, that is TW value, then R1, RY, RZ, everything you have to note. Even ZE value, that is ZEE value or ZEZ values. This value also you have to note down for the corresponding ISMB 400. All these values you have to note down in your answer paper. Okay, we'll continue. Now we got ISMB 400. For that, H value, BF value, TF value, TW value, ZP value and ZE value. Everything should be noted down from the page number 138 of the code book, right? Now we'll go the steel table now, right? We need R1 value, R1 and IX value. These two values are not there in the page number 138. We need these values, so that we have to go for page number 12 of steel table. That also I'll show. Okay, page number 12, where this I section, right? Wherever ISMB will come, that is I sections. So here see, you can ISMB 400 you will get here. If it is 200, 350 will be here. More than 500 means you will go to the next page, right? If you will have ISM 400, we need all the values also here also there. You can note on from here also, H, BF, TF, everything is here, right? So page number ISMB 400, we need R1 values. This is given in the next page, means the 15th 13th page, where R1 values here, the root at the radius, that is R1 values here. You'll check here, the ISMB 400 is here, first one. So here first one, that is R1 is 14 mm, that is 14 mm we got R1. Same way IXX value will be here, right? This is IXX value, cm, in terms of cm to the power 4 you will get, that is 20,458.4 into 4 centimeter to power 4. Unit also important. Okay, now got that here, 20,458.4 into centimeter power to the 4. If we want in terms of mm to the power 4, means you have to multiply with 10 raised to 4. Now we have to go for the page number 18 of the code book, right? Page number 18, I'll open the code book. Page number 18 of the code book. Wait. Okay, page number 18. There will got B by TF and D by TW. This is there in the page number 18. See, this is page number 18 of the code book, where we have to find out B by TF. One is B by TF, that condition is 9.4 E, and then here neutral axis at mid depth, that is D by TW, the condition is 84 E. These conditions should be remembered. One is this one and this two. So I have to find out B by TF and D by TW. B by TF is 70 by 16, B is 70. How we got B is 70? We have BF is 140, so BF is 140, B is BF by 2, that is 70 mm, and it got 70. TF is directly given 60 mm here, and that has to be divided by, then you will get 4.075. And D by TW is, D is, you have to find out by this formula. This you have to remember this formula, H minus 2 into TF plus R1. H is 400, minus 2 is 2 into TF is 16, and R1 is 14 mm. Then you will get D value 340. 340 by TW, that is 8.9, you will get 38.20. These two values, whatever 4.37 and 38.20, 4.37 should be less than 9.4 E. That condition is there in the code book itself. E is nothing but 250 by root y. E is always 1, remember. Okay, then you will get 9.4, less than 9.4, okay, and less than 84, okay. The section is plastic section. Okay, always you will be dealing with plastic section itself. You will get plastic section. Okay, then we have to go with the check for shear, check for bending strength, and check for deflection. If you are possible to go, then go with this, because it will not fetch more marks, checks and all. So till this design it fetch more marks. If you want full marks, then you have to go with check for shear and bending strength and check for deflection. So check for shear I'll explain here. If you want, you can go through. For the check for shear, first you have to find out Vu is equal to WL by 2. If it is simply supported, if it is cantilever, then the value Vu is W by 2, right? Vu is Vu is WL, not WUL by 2. Then your V is if it is cantilever, WUL, just WUL, that is if it is cantilever. Most of the times you will get simply supported, that's why I didn't solve. So you will get 76.2 is WU, initially you calculated, L is 5 meter given in the question, divided 2, you will get 190.5 kilonewton. Now you have to go for the page number 59 of the code book, where the shear VD value is calculated. Page number 59, I'll show the page number 59. There will be a formula, right? This formula we need, VD formula, right? Wait, I'll show. So this is page number 59. There will be a formula is given, VP, but it is VD. Take it as VD is equal to AVF by W by root 3. There is only this formula is not enough. Even here you have to multiply for the root 3 you have to multiply with gamma m naught here, that has to be multiplied here, root 3 gamma m naught, and whole multiplied by this hot rolled STW is there now, that has to be multiplied here in the numerator, and in the denominator you have to multiply with gamma m naught. This formula has to modify for the VD formula. Okay, we got the here VD formula here. See, AVFW root 3 and STW multiplied and gamma m naught multiplied in the, these two are extra from the code book. And AV is always 1, and FYW is FY, that is 250, and divided by root 3, and H is 400, we calculate from the steel table. TW also we got from the steel table, and 1.1 is gamma m naught, and we will get in terms of Newton, have to multiply with kilonewton. This should be more than whatever VU calculated. If it is more, then safe. Okay, then check for bending strength. How to go for the page number 53 of the code book. Here the formula is given. Okay, page number 53, there will be a formula here, right? Bending strength, MD is equal to VB ZP Fy gamma m naught should be less than 1.2 ZE Fy by gamma m naught. These two formulas, right? Okay, listen here. Whatever I written, MD is equal to VB ZP Fy by gamma m naught should be less than 1.2 ZE Fy by gamma m naught, and BB is 1 for plastic section, beta B, that is not BB, beta B, that is 1. Then ZP is whatever ZP we got from the steel table, that not initially we got ZP, not this ZP. How to calculate, go with the ZP of this value, whatever the selected ISMB is there now, for that ZP value 1176.18, that has to be taken, and ZE value also needed, ZE, that is 1020, we got from the page number 138 of the code book. So these two values should be there. Okay, here 1176, that is ZP, into 250 is Fy, gamma m naught is 1.1, 1.2 ZE, that is 1020 into 250 by 1.1. then you will get in terms of values, these two less than is there now, this equation if it satisfies, that is safe. Okay, then go for check for deflection. There is also delta less than delta max, so delta value is L by 300 and delta max is 5 by 384 into WL44 by AI. I think if you are possible to go with the check for deflection, then go with it, otherwise leave there, right? Because this formula changes for cantilever beams also. So an I is IXX, that is to the whatever the value we got IXX from the steel table. E is Young's modulus, that is 2 into 10 raised to 5 for steel. Then L is span 5000 mm. So 5000 by 300 is equal to 5 by 384 constant, and the W value is working load, not factored load, not ultimate load, 50.8 into 5000 to the power 4 divided by 2 into 10 raised to 5 into IXX value. You will get with the equation solved, so you will get safe. This is the first problem. In the second problem, the initial only changes. I will explain the initial stages. Later stages is same as whatever we calculate in the first step. Okay. In this problem, they given a room measuring 7 meter into 10 meter consists of 12 centimeter thick slab. They given slab thickness 12 centimeter and 7 into 10 is room dimension. And okay, they given the 2.5 spacings given in the question, this diagram. The floor finishing load may be considered as 1.1 kilonewton, that is for floor finishing load, FF load. Then live load 2 kilonewton. So assume FY is 250, bearing is 230. Bearing is nothing but thickness of the wall, that is 230 mm. Okay, now we got this diagram. This diagram is given in the question. There will be 10 mm in this side and 7 mm this side, that is 7 meter into 10 meter. Then then bearing, that is 0.23 or 230 mm, right? All the sides bearing will come. Okay, the spacing is 2.5. Now we have to go with the solution, that is span is equal to whatever L span is given in the question, that is shorter span, that is 7 meter, right? Shorter span I have to take, that is 7 meter, but we have to add the 0.23 wall thickness to get effective length, that is L plus 0.23, that is 7.23 meter or 7230 mm. Okay, first we have to go with the load calculation. Then is here dead load is not given, that is D into rho. D into rho. D is nothing but the slab thickness given, 12 centimeter. 12 centimeter in the sense 0.12 meter. 0.12 into rho is density of the concrete, that is 25 always. We'll get 3 kilonewton meter square lead load. Live load is 2 kilonewton. Then floor finish load is 1 kilonewton given. Total get 6 kilonewton. Spacing is 2.5 here, right? I have to multiply load with the spacing, 6 into 2.5, you will get 15 kilonewton. Then one more load is have to add, that is self weight of the beam. Self weight of the beam you will assume the 0.8. I told how to assume self weight. Then your total load is 15 here plus 0.8, you get 15.8. So ultimate load is W into 1.5, that is 23.7 you will get. Then you have to find out the moment, that is WL square by 8 because it is simply supported. Then ZP you have to calculate it, right? ZP value you have to calculate, whatever the ZP value 681 you got, you have to go for page number 138, and we selected ISMB 350 because the ZP value is 889.57, more than 681. So we got ISMB 350, all the properties of ISMB 350, everything written from the steel table also. Root R1 values and IXX value also written. Same way you have to go with the page number 18, where we have to find out B by TF and T by DW. B is BF by 2 and D is having separate formula. The condition is satisfied here, the section is plastic. So now we have to go with the check for shear. We use WL by 2. Then you have to go with the page number 59. Then you will get the same way, continue with the bending strength and check for deflection also. These are the two problems majorly appear in the exam. There will be one twist they can give, that is either they give as cantilever, so you have to change the formula, moment calculation formula, and then when you are going for the check for shear, there will be a VU value is different here. This value, this formula is different. Okay, if you are having still doubt, I'll clarify if you call, or still can contact me, right? And then one text they can give as dead load, live load, imposed load, all this. Then together they can give it as UDL, right? They'll say that the beam is subjected to a uniformly distributed load of 50 kilonewton or 30 or 45 kilonewton. Most of the time they'll ask 45 kilonewton. At that time, no need for dead load, live load, everything. They given togetherly. If they give like this, beam is uniformly distributed load of something kilonewton, they give directly that load you have to take, that is nothing but the total load. Then you can go with the next step is moment. No need of live load, self weight, everything they combined and given. Okay, these are the things to be remembered in the module 3.